In the previous video, we saw threat modeling frameworks that were mostly applicable to IT environments. And it's very useful to know different approaches so as to inform our own approach when we're targeting specifically OT environments. So again, we saw Stride, Dread, and Pasta. Here in this video, we'll focus on an OT-specific framework that is called Mitra ATT&CK framework. So this framework, the Mitra ATT&CK for industrial control system, classifies malicious cybersecurity events against an operation technology environment. So it tries to reflect the distinctiveness of physical operational environment and provides explicit classification for the effect an attack might have on OT assets. There are four fundamental concepts behind the philosophy of attack for ICS, and the first one, very important, is to maintain the adversary's perspective. So we look at the threat model from the lenses of the attacker. So the attack, how can I attack my system? Can I do this? Can I do that? How do I go through persistence, lateral movement, command and control? So always maintain the adversary's perspective, and that's a very important concept behind this framework. Second, this is an evolving framework. So it incorporates and refines based on real-world event activity. So once we have a new attack, then we can go back to the framework and add the new techniques, new tactics, maybe different assets we're targeting, or how the functional levels were affected by the new attack based on the real-world incident. Third, the content is represented with appropriate level of abstractions. There's assets, their functional levels, their tactics and techniques that are all in a different level of abstraction, so we can approach every possible threat with the appropriate countermeasure on the appropriate layer and level of abstraction. And the last one is the last concept is to underscore the failures and consequences that can arise from adversary behavior. So once this happens, what is the effect on the system? What can happen if the attacker manages to get to the point? And because the framework is following a chain, then every chain has different steps, and in every step, we can see what is the next thing we can do once the attacker is there. Because I may have repeated several times, it's not about only keeping the attacker out, but it's also what happens if the attacker manages to get in and tries to move around the system. We have to have the defense in depth approaches to make sure that at every step we have appropriate countermeasures. So the Mitra ATT&CK framework has four core components. The first one is the functional levels. We saw previously the Purdue reference architecture from level 0 to level 5. Level 0 to level 3 were mostly the control environment, and level 4 and level 5 was the business enterprise environment. And it's important to focus on functional levels because attacking different levels can have different effects on the system and also the different assets associated with each level. So at the lowest level, you have more control components, sensor actuators. At the high level, you have more regular computers, PCs, smartphones, and printers, standard IT equipment. So it's important to first abstract the functional levels. And then the assets, a second component of the framework. So we have broad asset classes to represent the functional component of the systems. We have HMIs, SCADA servers, data historians, but you have your regular computers as well, or your smartphones and printers. Third is tactics. So tactics are the adversary's tactical objective. So why is the adversary doing something? Is the adversary trying to impair the process? Is the adversary trying to do something else? So it's a more high-level objective, and to achieve that objective, the attacker uses a technique. So the techniques represent how an adversary achieves the tactical objective through some action. So to impair the process control, as we saw in the tactic component, you can maybe modify the firmware, and we've seen real attacks doing that. So let's dive into detail about each one of these components of the framework, starting with number one, the functional levels. The functional levels in the Purdue model go from level 0 to level 5. Between level 3 and level 4 is where we used to have the separation between the OT and IT. Now, due to the convergence, we can think of the leveling as a hierarchy that is connected throughout. So level 0 is the equipment under control, sensor and actuators. Level 1 is the basic control, your protection and local control devices. Level 2 is the area supervisory and control, site monitoring, local display, followed by level 3, operations management, system management and supervisory control, and then levels 4 and 5 are the enterprise systems. So more on the IT side. So in here you would see regular computers, and this is level 3, and between level 3 and level 4 you connect to your control environment. And it's important to have the functional levels because the second component, assets, we need to understand the asset classes per functional level. So if we go and describe more the asset component of the framework, we can see here on the right side, I have the example from the NIST guidelines, the control center connected to different parts of the system, and then every asset has some properties, 2 properties actually. One is the function, what is the functional level the asset is typically associated with in the Purdue architecture. Is it level 0, level 1, level 2? And then is the platform. What is the hardware and software platform of the asset? So in example, let's say this RTU here, this can be, let's say, level 1, and while valve and pulp will be level 0, the actual sensor and actuators. So this can be level 1, and in terms of function, and in terms of platform, this could be an ARM processor running a Linux operating system. And this is very important to note, because if there's a new vulnerability affecting Linux systems running on ARM, then you can go back to your assets and understand what are the levels, what are the effects based on the level the asset sits on that can happen in your system. Other assets here, the HMI, data historian, the modem is also very critical in the communication path, engineering workstation, printers, everything has to be properly classified as an asset with its function and its platform. So once the assets are in place, now we're moving more into the tactic side. What are the high-level tactics the attacker has, and then we'll connect them to assets and functional levels. So the tactics approach follows some form of a chain. So from the initial access all the way to the final impact, we can think of the tactic side as a progression of the attacker moving through the system. So the attacker first needs to get into your ICS environment. So the first tactic would be the initial access. And after in the system, they will try to run malicious code in order to have to maintain persistence, to maintain their foothold in your ICS environment. Once they're in and have persistent, then they will try to avoid being detected within some evasion tactics. Once they remain undetected, then discovery, they will try to figure out what the environment is to be able to continue the attack and move laterally into through the ICS environment. As soon as they move, they start collecting data of interest and domain knowledge on the ICS environment to inform their final goal. But the goal could be moving. They could be getting dynamically commands through a command and control center. So once the adversary is in the system, the malware may be asking command and control servers for further instructions on how to proceed in the ICS environment. And the new commands can do, for example, first inhibit the response function, like what Triton did, prevent safety operations from properly working, causing some failure or unsafe states, or as more advanced, try to directly impair the process control, similar to what maybe Stuxnet did by destroying equipment. And the last, the biggest thing that can happen is a direct impact to the process by manipulating, interrupting, or destroying ICS systems, data, and their surrounding environment. Again, tactics is more of a chain that starts from initial access and goes all the way to the impact. And every tactic, in order to succeed, some technique has to be used. So techniques, again, represent how the adversary achieves the technical objective. And now the table becomes a bit bigger. Here on the top, the top row are the tactics again: initial access, execution, persistent, evasion, discovery. And then for every tactic, there are a few techniques that either come from real-world events or they're a result of threat modeling on behalf of the experts in order to inform the framework. And remember, the framework keeps evolving. So if we see a new way of achieving a tactic, then this will be added as one of the techniques that make the tactic possible. So let's go to the web page in order to see some of these techniques, because you can actually click on each one of them and you'll get more information about how you can deliver that and how you can actually protect against that. So let's start on the initial access. There are different ways you can get your initial access to the system. You can compromise the historian, you can compromise the workstation, maybe one of the devices is accessible to the internet, as we have discussed in the past, so you can compromise that. Spear phishing, if you remember, this is how the Ukraine attack started. And again, the benefit and the great thing about this framework is that it is being developed using real-world events. So let's go to that technique, spear phishing attachment. And you can see actually there are many more examples that show how of attacks that used spear phishing in order to get this initial access to the system. So you have Dragonfly, Oil Rig, Black Energy, different malwares that they do spear phishing in order to get the initial access to the system. And to mitigate against that, there's some sample mitigation. You can have antivirus malware. Remember, these attachments can be detected by, if they're malicious, they can be detected potentially by antivirus. Network intrusion prevention, restrict web-based content. Now if you open Office document, Office will warn you that this is something downloaded from the internet, so macros have been disabled or code execution could have been disabled in order to protect against similar attacks. As for spear phishing, on the execution side, how you actually manage to execute code, there are different ways. Let's go to maybe scripting, and you can read what kind of, so scripting is following naturally the spear phishing, because in Office you have the Visual Basic macros that allows you to execute code that will do something in the document, but in case something goes wrong in the system and there's some kind of exploit possible, then the attacker can manage to run code, and the code can lead to some effect that is the next tactic that will lead to persistence. So we can be going through it, the whole process, and you can feel free to navigate. It's very useful to go through the whole table and see all these tactics individually to get informed of how the attacker, what kind of tactics the attacker can use, what kind of techniques the attacker can use in order to compromise the system, and see sample defenses for each one of them. So the idea of the threat modeling here is that you would go through the chain, and then you would see each one of these possible techniques and see what do you do to protect against them. Is it worth protecting against them? Is it applicable to your system? Maybe you don't have internet accessible devices, so this is not applicable to you. Removable media, you may disable the use of USBs in your system. Spear phishing, you may disable downloading of attachments, but then this could create business operation problems in the company or the utility. So you go through each one of them and you try to identify, is it applicable to my system? Is it worth protecting against? And once you finish that, you have actually a very good idea about the threat model, about possible threats that have affected already ICS systems, and the ability of your system, of your approach towards defending against the specific attacks.